Hello guys, what's up? We are back again with another question. And today the question is from the contest kth smallest amount with single denomination combination. So let us understand what this problem is and how we could have approached this problem. So the problem states that we are given an integer array. We are given an array nums which is named as coins and an integer k. Now these coins, for example, coins is 369. So what they are saying is that we have infinite denomination, infinite coins of denomination 3, 6 and 9 respectively. Now we can take any number of 3 coins, any number of 6 coins, any number of 9 coins, and we need to find the kth smallest amount that can be made using these coins. So for example, if this is the example 3, 6, 9 and k equals to 3, then what we can think of is 3, 6, 9, 12. 6 is 6, 12, 18, 24. 9 is 9, 18, 27, 36. So the third smallest. Okay, so essentially what we need to do is we need to list down the multiples of this, find out the multiples of this, find out the multiples of this, and then what we need to merge them. If we had a merged array without the duplicates, then we can find the kth smallest element. That was the case. So let us see the constraints. See, coins of length is okay from 1 to 15. Coins of I is from 1 to 25. But K is very, very huge. Yes. K can vary from 1 to 2 into 10 raised to power 9. That means there is no scope of making an array and applying something like merge K sorted arrays. There is no scope of that. So we need to think something else. But I can see that my coins of I and coins dot length, these arrays are of smaller size. So I can think of treating them. Okay. Now what we can think of is what can be the answer range? Yes. What can be our answer range? So I know that K varies from, okay, coins of I varies from 1 to 25. So if I had all the values of 25, if I had all the values of 25, and let's say I took K, maximum K, which is 2 into 10 raised to power 9. So what will be the kth smallest element? That will be nothing but 25. That will be nothing but an AP, right? With a common difference of 25 and a first term of 25. So A plus N, what is N? N is this much. So 2 into 10 raised to power 9 into D, and D is also 25. Minus 1, of course, will be there. But this will be the approximate maximum value of our answer, which we can have. So we can approximately take it as 1E11. Yes, 10 raised to power 11. Now let us see what we are trying to do. Now, can I say that we have a search space? Can I say that we have a search space from 1 and maximum, at max, we can have 10 raised to power 11. Because K is so much long, so, and we have a search space, we can think of a binary search. Yes. Now let us understand some code now. See, we have our lower limit as 1, upper limit as 1E11. Now, I will take mid. What I will take? I will start doing binary search and I will take mid as my value and try to find out the count. What the count indicates. Okay, so I considered mid as my answer. Now I am trying to find the K. Yes. So if count matches k, then I have my answer. Yes. If count matches k, then I have my answer. So I deduced the search space. Then I find out the then I tried for m. Then I will try for m. And if the count matches k, then m is my answer. So let us see the find count function. How will you count? Now we have the x. We have what we need to make after taking the coins. But we need to, and we need to find what we need to find. We need to find the count for that. Yes. So what which smallest is the number it is. So now I can do this using generating all possible combinations. Okay, first we need to understand one thing before that. See, this is something like this. I have a contribution. Let us say there are only two values. So let us say there are two numbers. So I need to count the contribution of this and this minus the contribution of this, essentially. So what is the formula? A plus B minus A intersection B. Yes or no? Contribution of A plus contribution of B minus A intersection B. Similarly, we can extend this formula for three terms. We will realize that odd number of terms, whenever there are odd number of terms, they are added. And whenever the terms are even, then they are subtracted. For sure. So now what are the number of terms? Number of terms are 2 raised to power n minus 1. And here we can use, and hence we can use something like bit masking. So just a second. So what I will do in this function, I will generate a mask. Yes. This will be all ones. I will generate a mask. This will be all ones. And I will have a count as 0. Now I will iterate. See, nn will be 2 raised to power n. So I will from 1 to 2 raised to power n minus 1, I will iterate. And I will find the LCM. Now how will, because LCM will tell me what thing I have to deduce. That is, what are the extra thing. Okay. So if 3 and 6 are the numbers. So I will take 3, 6, and from here I got 6. And let us say I need the second smallest number. Yes. So in the answer, I will have 3, 6, and from 6, it is coming 6. So I need to reduce, I need to, yes, reduce it by 6. So I will divide it by LCM, my x answer. Yes. So I will traverse from 1 to 2 raised to power n minus 1. And the inner loop, I am taking all the possible consideration of elements. For, let us say, for I is equals to 1. I is equals to 1 to 2 raised. So I am catering all the 2 raised to power n minus 1 terms. And for that, I need to, for each, I need to traverse the whole array. And those whose ith bit is set, I am taking that. So I am taking their contribution. And what I need to remove is the LCM from that. Okay. And then Once I got the LCM, once I traverse the whole array for that particular I, then I will count whether it is odd, whether the I had odd number of terms, odd number, or even number. So if there are odd, then I will add it. If there are even, then I will subtract it, as we saw in the formula. Finally, we return the comment. So yeah, guys, this was it from the question. Thank you so much, guys. We shall see you next time.